Okay, so hello everyone. In this mini lectures, we will talk about the way we're going to deal with some special type of integrations, which is the integration that contain some tricky trigonometric function. So the goal of this section is you will know the idea is how should we deal with the tricky trig integral, like for instance, the integrals of cosine to power of 5, the integrals of sine cubed times cosine to power of 7, tangent to power 4, etc. So far we have developed two methods to help us find the integrations. The first one is the use substitution method. The second one is integration by part. So if you have no ideas about these two things, I recommend you should go back to lecture number 1 and lecture number 3 to have an overview about these two things, or you can work on the problems, homework problems, so that you have the better ideas about these two methods, because we're going to use them to help with these with to deal with this type of integration. And because this is the integrals of the trig function, so you also need to know a little bit of trig identities, because there is sometimes the trig identities can help you simplify your function that you have. So for instance, if you have the integrals of sine square of x plus cosine square of x equal to 1, for instance, I'm sorry, dx. Okay, it looked tricky, but the point is we know that sine square plus cosine square is 1. So this integral just turned out to be the integrals of 1 dx. You just simply have x plus c. So sometimes the trig identity can save you a lot of times when you deal with tricky integral. And we also have the reduction formula. So the reduction formula will help you deal with something like this. So over here, I have list out the 4 reduction formula. So these reduction formulas is for to help you deal with the integral when you just simply have cosine, sine, tangent, or secant to power of something. So you pretty much have, you can see that you have the integrals of cosine to power of n. It turned out into this function plus the integral of something. In this integral, you still have the cosine function, but the point is the power is reduced by 2 units. So at some point, the powers would tend to 1 or 0. So if you have the integrals of cosine to power of 1, it's just the integrals of cosine. Then you have the basic integral. If you have cosine to power of 0, that means you just have 1, because anything to power of 0, anything to power of 0, it's just 1. So this is the points of reduction formula. So the reduction formulas will help you deal with the trig integral where you have the high powers. Okay. Okay, and one more things for the identities and the formulas for the integral, especially for for the reduction formula, you will be provided on the exam, so you don't need to remember these things. Okay, so there were two main things for this mini lecture. We will deal with two type of special integral. The first types of integral will be the integral that contains sine and cosine to power of something. Okay. The second types of integral is the integral that contains tangent and secant to power of something. So in this video, I will mainly focus on the integrals of sine and cosine. And in the next video, we will work with the integral that contains tangent and secant. Okay, so the point is, so over here, I consider the general types of integral. So that means you can have any kind of powers for sine and cosine. So the powers m and n can be an even numbers or an odd numbers. You don't know exactly what you're gonna have, but I will give you the general way to deal with uh, all of the cases that you may have. So the first case you may encounter is the case where m is the odd number. Okay. So if m is the odd number, that means if the power of psi is the odd number, then you will use the trig identity and the u substitution to solve your integral. In the particular way, you will solve the integral in this following way. Firstly, you will split psi to power of m into the products of psi to power of n minus 1 times psi. Okay, this is the first step. Okay, and then um, and then because m is the odd number, so when you subtract 1, that means m minus 1 will be the even numbers because you have odd numbers and you go down 1 unit. You should have the even number. Okay. When you have an even number, then you can rewrite psi to power of m minus 1 as psi squared to power of m minus 1 divided by 2. Okay. And over here, I will translate psi squared into 1 minus cosine squared because you know that you have this identity psi squared of x plus cosine squared of x equal to 1. Okay, this is the famous identities for the trig function that you should know. Okay, so again, m minus 1 is an even number, so I can rewrite this thing. I can rewrite sine to the power of m minus 1 at psi squared to the power of m minus 1 divided by 2. The reason is I want to translate psi squared into cosine squared. Okay. Okay, so use the trig identities. I rewrite sine squared as 1 minus cosine squared. And up here, now we can do this, the substitution method. Over here, you can see that you have the function in terms of cosine, and you have some extra function psi of x over here. You have some extra function. The rest part is the function in terms of cosine. So that this is the perfect things to do the u substitution. You just need to set up u equal to cosine of x. So when you set up u into equal to cosine of x, when you take the derivative of u, the sine of x will appear, and that is the extra thing you have saved at the beginning when you split the powers of sine. This is the thing you save at the beginning when you split the powers of sine. Okay. The rest thing over here is the function in terms of cosine. So you will use this u substitution method to solve them. So this is the function in terms of cosine. So I will introduce the new variable u as cosine. So when I take derivative, I have sine dx. Okay, so that means I have from here I have negative du is sine of x dx. Okay, so that means I can rewrite my integral in terms of x as the integral in terms of u. And over here, we rewrite things. So 1 minus cosine square is 1 minus u square. Okay. Cosine to power of n will be u to power of n. Okay. And sine of x dx is negative du. So I have the negative sign up front and I have du. Okay. Let me repeat once again. You have some extra functions over here. That extra function is sine. And over here, the rest thing is the function in terms of cosine. And you can do a little bit of imagination. You can think derivative of cosine is sine. So you decided that you will use the u substitution. So when you do that, you take derivative of u, the extra thing that you have over here will appear on the right hand side. So you have an evidence to translate this thing, which is the integral in terms of x, into the integral in terms of u. You have u equal to cosine, so 1 minus cosine squared is 1 minus u squared. You have cosine to power of n, so you have u to power of n. Okay, and sine x dx is negative du, so I have du and a negative sign in front. And believe me, this thing is much more easier to find integral. And I will demonstrate one of these things in the next page. Okay. So over here we have, let's try out one case. So over here, this is the strategy you use when you have n as the odd power. Okay. So up here, sorry, I should have this one as case number one. Let me justify a bit. This is case number one. This is case number two. Okay, so let me demonstrate the thing that we have discussed. What should we do if you have the integrals of sine times cosine to power of something, and the powers of sine is the odd numbers? Okay, so in this example, you see that you have sine to power of 5. Okay, so 5 is the odd number. So to deal with this problem, first step, you're gonna split the powers of sine. You're gonna split the powers of sine. Okay, you're gonna split them. You have sine to power of 4x. Okay, cosine to power of a, and you have sine of x because you split them. You split them out. Okay, and you're gonna save them. You're gonna save them because this thing will appear when you do the u substitution. Okay, the second thing you have to do is you have to translate the rest part into cosine. So this thing is already cosine. You only need to translate this thing into cosine. So we were gonna use the special trig identities. Firstly, you should rewrite this thing in terms of sine square. Okay, so I have sine to power of 4. I can rewrite sine to power of 4 and sine squared to power of 2. Okay, you try to rewrite this thing into sine squared to power of something. Okay, this is the second step. I have cosine to power of a, which is rewrite again, sine of x dx. Okay, and now we use the special strict identities. We know that sine squared is 1 minus cosine squares of x. Okay, up here we use the fact that sine square plus cosine square of x is 1. That means sine square of x is 1 minus cosine square of x. Okay, so I just replace this thing by 1 minus cosine square. And I have cosine of to power of a x sine of x dx. Okay, so now I expand my integral. Sorry, let me do the u substitution. Okay, this thing is a function in terms of cosine. This thing is the sine of x. So we're gonna use the substitution method. We set up u equal to cosine of x. So you will have du equal to negative sine of x dx because the derivative of cosine is negative sine. So negative du will be sine of x dx. Okay. So now you have your integral. You can rewrite your integral in this way. You have u1 minus cosine square will be 1 minus u square because cosine of x is u. So cosine square is u square. I have 1 minus u square square. This is cosine to power of a. And u is cosine, so I have u to power of a. Okay. And sine of x dx will be negative du. So I have du with the negative sign in front. And now we're gonna expand the square that we have. You're gonna have 1 minus 2u squared plus u to power of 4 and u to power of a du. You can check on this one by using 1 minus u squared times 1 minus u squared. So when you distribute these two parentheses, you're going to have 1 minus 2u squared plus u to power of 4. Okay, and now we have negative sign in front. We distribute u to power of a into this parenthesis. We have u to power of a minus 2u power of 10 plus u to power of 12 du. And then we just use the power rule to finish our integration. Okay, we have negative sign u to power of 9, u to power of 9 divided by 9 minus 2u to power of 11 divided by 11 plus u to power of 13 divided by 13. Okay, and after you finish integration, remember to add constant c. Constant c. And one more thing, remember to return this thing into the function in terms of x. And initially, we set up u equal to cosine of x. So I will have cosine to power of 9 divided by 9. Okay, I have 2 cosine to power of 11 x divided by 11. I have cosine to power of 13x divided by 13. Okay, move this thing a little bit. Oh, I'm sorry. Move this thing a little bit. And plus c. Okay, so this is how we deal with the tricky integral that have sine and cosine to power of something. So we're gonna use the trig identities and use substitution method. Okay, the next type is similar. I'm sorry, this one is n is up. Okay, the second case is also similar. But in this scenario, instead of having the powers of m as the odd numbers, you will have the powers of cosine as the odd numbers, and you will do the same thing. So instead of split the powers of sine, you will split the powers of cosine, okay? And then you will try to rewrite the resting in terms of sine, because you save cosines over here. So you will try to write down the resting in terms of sine, okay? So firstly, again, when I look at the function and I notice that the powers of cosine is odd, so I will try to rewrite the cosine to the n as cosine to the n minus 1 times cosine. And I'm gonna save this thing. I'm gonna save cosine of x dx. And similar things, the n minus 1, because n is an odd number, so n minus 1 will be an even numbers because you go down 1 unit. Okay. Okay, so you have you can rewrite the cosine to power of n minus 1 as cosine square to power of n minus 1 divided by 2. Okay, and then you're gonna use the special identities. You can rewrite cosine square at 1 minus sine square. Okay, you can again we use sine square plus cosine square equal to 1. So that means cosine square will be 1 minus sine square. So I have 1 minus sine square. Okay, now you have some extra function cosine times dx. The rest thing is the function in terms of sine. So this is the perfect situation to use the u substitution. You just need to set up u equal to sine of x. Okay, you set up u equal to sine of x. So we have du equal to cosine of x dx because the derivative of sine is cosine. Okay, so then you can rewrite this thing into the integral in terms of u. So sine to power of m will be u to power of m. Okay, sine of x is u. So sine to power of m will be u to power of m. I have u to power of m. 1 minus sine square will be 1 minus u square because sine is u. Okay, sine is u. So sine square will be u square. I have 1 minus u square. And cosine of x dx will be cosine of x dx will be du. I have du. And again, this thing is much easier to take the integral. Okay, so let's try this one. Let me save some space for us. So that okay, so this is for case number 3. Okay. Okay, so you look at this thing, and you notice that the powers of cosine is odd, so you're gonna split the powers of cosine. Okay, so I don't really care how much you remember this thing. So the tip is if you look at these two things and one of the powers is the odd number, you're gonna split the power of that thing. Okay, so up here, I don't really care about sine to power of 4 as well because I look at cosine and I have an odd power, so I'm gonna split this thing. Okay, so firstly, we can rewrite this thing as cosine square of x times cosine of x sine to power of 4 x dx. Okay, I'm gonna save this thing. Okay, so I have cosine square of x sine to power of 4. I just rewrite it again, but I've saved cosine of x dx. Okay, because this thing gonna appear when I use the u substitution. Okay, and I would try that. I would try to write down the resting in terms of cosine. Okay, remember that the first step is you split the power. The second step is you would try to write down the resting in terms of sine. Okay. Okay. So we know that cosine square is 1 minus sine square of x. Okay. And this is already the function in terms of sine. So I don't rewrite. I don't need to do anything. I just have sine. I just need to rewrite sine to power of 4 again. I have cosine of x dx. Okay. And now we do the u sub. Okay. This is the function in terms of sine. Okay. It's like the function composition and the inner function is sine of x. Okay. So we set up u equal to sine of x. So when you do that, when you take the derivative both sides, you're going to have cosine of x dx, which is the extra thing you have in your integral. So now you can rewrite your integral in this way. 1 minus u squared. Okay, because u is sine, so you have sine square, which is u square. And again, sine is u. So if you have sine to power of 4, that means you have u to power of 4. U to power of 4 cosine of dx. Okay, I'm sorry. Cosine of x dx. Cosine of x dx is du. So I have du. And this one is much easier to integrate. You distribute u to power of 4 into the parentheses. You have u to power of 4 minus u to power of 6 du. And then you can use the power rule to finish this one. You have u to power of 5 divided by 5 minus u to power of 7 divided by 7 and plus the constancy. And final thing, remember to translate this thing back to the function in terms of x because initially you have the function in terms of x. So initially we set up u equal to sine of x. That means you're gonna have sine of x to power of 5 divided by 5 minus sine of x to power of 7 divided by 7. Okay, plus c. Okay, so this is the technique you need to know when you encounter with the integral that contains sine and cosine. and one of the powers is the odd number. Okay. In the second things, in this now we come to the last case. What if n and m are both even? Okay, so that is scenario when you look at the integration that contains sine and cosine, but both of them contains even power. Okay, so let me try with the first case. Let me try with the similar case. In this case, I mean the technique to deal with this thing is you're gonna use the trig identities, or you can use the reduction formula. Okay, there's two ways. You can try to use identity to simplify your function, or you can try to use the reduction formula to help you compute the integral directly. Okay, so let me try with the first case where you try to use some trig identity. Okay, and you're gonna try to rewrite your integral in terms of cosine of 2x. Remember that you're gonna try to rewrite your integral in terms of cosine of 2x. Okay, now we go into the first case. So in this scenario, you have cosine to power of 4. Okay, and remember that you have one special trig identity, cosine square of x equal to 1 plus cosine of 2x. I'm sorry, we should have the 1/2 in the front. 1/2 cosine of 2x. Okay. So we call this thing as the doubling angle. So you reduce the powers of your function, but you have to double the angle you have. So from x to 2x, but now you can reduce the power from 2 to 1. And if you can reduce the power into 1, that is much easier because you have the basic integral. Okay, you have the basic integral for cosine of x, for instance. It just simply becomes uh, sine of x. Okay, so if you can reduce the power, that's a good thing. Okay, but up here, thing is a little bit trickier because you have cosine to power of 4. So firstly, you should make cosine square up here. And because this thing is the even number, so you can easily rewrite this thing as cosine square to power of 2. I mean, even if you have cosine to power of 6, for instance, you can you're still able to rewrite into cosine square, and you just write to power of 3. So that is not a big problem because this is the even number. So you're only able to write down something into cosine square, and you write to the power of something. Okay. So then I rewrite cosine square as using this identity. So I just replace cosine square by the doubling properties of the trig function. After I have this thing, so I have 1/2 and I square it. So I have 1 to power of 4, and rewrite 1 plus cosine of 2x again. And then I expand the square. Okay. I'm gonna have 1 plus 2 cosine of 2x plus cosine of 2x squared. I mean, you can check on this thing by just simply have 1 plus cosine of 2x times 1 cosine of 2x. Okay, if you distribute these two things, you're gonna have this. I mean, you distribute and you simplify, you're gonna have these things. Okay, so over here, you have the integrals of a sum. So it just turns out to sum of integral. This is the property that you learn in Calc plus 1. So I have the integrals of 1, I have the integrals of cosine of 2x, and I have the integrals of cosine square of 2x. Okay. And for this one, you have again you have cosine square, but again you can reduce the power again using the trig identity. You can double the angle to compensate for the power. So from here, the power from 2 becomes 1, but you have to doubling the angle. You have to double the angle. You have 4x. Okay. Okay, so now we have pretty much set up everything. The integrals of 1 is x. The integrals of cosine of 2x will be sine of 2x. I mean, the integrals of cosine is sine. Over here, I forgot to mention one thing. I also give you these two things. I mean, the integrals of cosine is sine, the integral of sine is negative cosine. But if you have some numbers in the front of x over here, then sine still give you negative cosine, and cosine still give you sine. But remember to divide it by n. Remember to divide it by n because of the extra coefficient over here. You can prove these two things using the substitution method. It's not a big problem. So, but the point is, I just need to remember if you have sine of something multiplied by x, sine still return you negative cosine, like this one. Sine still return you negative cosine, but you have to divide it by n. And if you have cosine of n to the power, if you have cosine of nx, then cosine still return you sine. Cosine still return you sine of x, but you divide it by n. Okay. So going to this one, you have sine of 2x. So sine of 2x will return you, I'm sorry, you have cosine of 2x. The integrals of cosine will give you sine of 2x. But remember to divide it by 2, which is the coefficient in the front of x. And up here, you have 1/2 times 1 plus cosine 4x because of the doubling angle. Okay. This is cosine of 2x, cosine square of 2x. So when you reduce the power, you have to double the angles of this thing. So double the angle of 2x will give you 4x. Okay. You have 1/2. The integrals of 1/2 give you 1/2 x. The integrals of cosine of 4x will give you sine of 4x. Okay. But remember, you have to divide it by 4. Okay, because of the extra coefficient you have in the front of x. Okay, so 1/2 x and 1/2 times 1 to the power of 4 sine 4x. Okay, so now we are done with the integrations using the trig identity. Okay, we try to use the trig identity to simplify the function that you have. I mean, the point is you try to reduce the power into the powers of 1. Okay, you try to reduce the power of the cosine into the cosine to power of 1 only, because if you have cosine to power of 1, that means you just have the basic integral. Okay, you have the basic integral. Sine becomes negative cosine, and cosine becomes sine. Okay, that is what I meant. You can also use the reduction formulas if you want to. Okay, you can use the reduction formula if you want to. So this is the reduction formula. Okay, cosine to power of n, sine to power of n. 10. Okay, you can use these two things. Okay, so for instance, over here, I use reduction formula. I have cosine to power of 4. Okay, so let me copy down this thing because actually I don't remember this thing at all. Okay, copy down. We're gonna copy these things down. Okay, so this is the reduction formulas for cosine to power of n. Okay, so over here you determine that the powers of the power n is 4. So I have 1 over n, which is 1 over 4. I have sine of x. Rewrite again. Let me rewrite this in this way, so that you can see the similar thing in the formula. Okay. Sorry for uh, confusion. Sine x cosine cube x. Okay. You have sine of x, so you have sine. We have 1 over n. You have 1 over 4. This is sine of x. You have sine of x. Cosine of n minus 1, and n is 4. N is 4. So I have cosine of 4 minus 1, which is cosine cube. And over here, I still have the integral. Okay, but the coefficient is n minus 1 divided by n. So you have 4 minus 1 divided by 4, which is 3 over 4. Okay, and the integrals of cosine of n minus 2, and n is 4. Okay, n is 4. N is 4. So I have cosine 4 minus 2, which is cosine square of x dx. Okay. And over here, again, you can continue using the reduction formula. So over here, you determine that this is the integral in terms of cosine, and you have cosine to power of 2. So you can determine that the power of n over here is 2. You are still able to use the reduction formula. So because n is 2, so you have 1 over 2. You still have sine of x. Okay. Sine of x. Leave sine of x. Okay. You still have, I'm sorry, let me do it again. So over here, you have cosine square. This is cosine to the power of n. So n is 2 in this scenario. So you have 1 over 2 sine of x. You write again. You have cosine to the power of n minus 1. So you have cosine to the power of 2 minus 1. Because now in this scenario, n is 2. The power you have is 2. So you have cosine 2 minus 1, which is cosine of x only. Okay. And then because n is 2, so you have 2 minus 1 divided by 2 for this one. So you have 1 half. Okay. And again, because n is 2, so you have cosine to power of 2 minus 2, which is cosine to power of 0. And cosine to power of 0 is 1, because anything to power of 0 is 1. Okay. So you simply have 1 half. Okay, you just simply have 1 half, and integrals of 1 half is 1 half x. Okay, so 1 half x times 3 over 4 give you 3 over ax. Okay, and up here, I'm sorry, I don't know why I used u, but it should be x. Sorry for the confusion again. So over here, you have 3 to the power of 3 over 4 times 1 half. You have 3 over a sine of x cosine of x. And this thing is not an integral, so you just simply write again. Okay. And I mean, if you notice the answer you have, I mean, these two, the the integrals of cosine to the power of 4. This is also the power to. This is also the integrals of cosine to the power of 4, but the result that you obtain is quite different. The result you obtain that is quite different. But it doesn't mean that you are wrong in this scenario, because you know that the trig function, they have a lot of trig identities. They have a lot of trig identity. So maybe the thing that you have can look quite different, but they are really the same thing. They are really the same thing. You can check by using AI. You can put them and say that are they the same thing? They really are. They really are the same thing. So it's not a big problem. Like if you solve this way, if you solve the problem in this way and you get this result, and your friends use the regression formula and they get the different result, but actually they are still the same thing. Okay. I mean, you can use the trig identity to rewrite this result into this result. It's not a big problem. It may take time, but it's not a big problem. But the point is, you just need to finish integrating these questions. So so if n and m are both even, you can use the trig identities, or you can use the reduction formulas. It depends on the case. Um, Okay. Some other example. I mean, over here it's still quite easy because you have cosine to power of 4, and you don't even have sine of x inside your integral. But if you have sine of x, for instance, over here, and have sine square of x, okay, and both powers is even, both power is even. So over here, firstly, I rewrite sine square as 1 minus cosine square. Okay. So I have cosine. Again, I use the trig identity. This is the famous identity you should know for the trigonometric function. Okay. And then you have cosine to the power of 4. Okay. You have 1 minus cosine squared times cosine to the power of 4. You distribute this thing into the parentheses. You have cosine to the power of 4 minus cosine to the power of 6. Okay. And again, you can use the reduction formulas, because this is just simply, I mean, you can rewrite this thing as the integrals of cosine to the power of 4 dx minus the integrals of cosine to the power of 6 dx. Okay. And then you can use the reduction formula for this one, these two things. Okay. So remember that if you want to use the reduction formula, you have to reduce the power until the power of cosine becomes zero, so that you just simply have one. Okay, but I don't want to write out this thing because to me it's just applying the formula, so it it doesn't not a big problem if you want to continue. So I just leave my answer like this one, but you can actually write down your result using the reduction formula. Okay. So in the next video, we will continue discussing the trig integral that contain tangent and secant. So I will see you in the next video.